This month we took Project STI to renowned Subaru specialist MRT Performance to have the fuel system upgraded.
Hi, I'm Brett Middleton. This is MRT Performance.
The installation of MRT spec fuel rails, fuel pump and surge tank are not horsepower increasing modifications, but were done to ensure the horsepower we have is on tap under all driving conditions, particularly competition applications. Additionally, they were done to ensure the STI would receive adequate fuel supply when we upgrade the turbo network and the subsequent increase in power.
The fuel rail is a CNC billet machined component made out of obviously aluminium. The main design feature of it you can see is it's got a high capacity, so for in immediate load situations when you might be slamming the foot to the floor and wanting demand on the fuel injectors, you've got a reserve of fuel pressure there. The particular design of the fuel rail is significantly different from the Subaru factory fuel rail system in that it splits the two main long fuel rails, which are connected together by the inlet and the outlet at either end, into two smaller rails. Now the big advantage of that is you've got less distance for the fuel to supply to the injectors, and also you've got more control because we've actually added an additional fuel pressure regulator to the system because we're splitting one from the other. We reuse the factory supply one which is on the car that you see that we remove and refit, and we also supply a brand new one as part of the kit. So when the kit is completely fitted, you've got a very, very short distance for the fuel entering the rail and exiting the rail via the regulator, and also obviously supplying the important delivery of fuel to the injectors when you need it most.
MRT have spent years developing engine upgrades for Subarus, from mild power upgrades for street cars to big horsepower circuit strip and rally cars. The company's extensive R&D on these power-up kits eliminates concern about effectiveness and reliability. MRT started by replacing the standard fuel rails with the company's own custom-made anodized alloy fuel rails. This is not a simple procedure due to the complexity of the boxer engine setup. So much of the components that sit above the block must be removed to allow access to and removal of the inlet manifold. Long-serving MRT mechanic Michael performed the conversion, which usually takes about 3 hours. It begins with the removal of the breather pipe, both ends of the intercooler pipe that runs to the throttle body, the blow-off valve, the bracket, and clamp off the opposite intercooler pipe, and the two clamps that pin the pipe to the turbo housing. Then he unplugged the airflow meter and the cold air pipe, disconnected the accelerator and cruise control cables, removed the belt cover and disconnected the alternator wiring, which was taped up so the power didn't have to be disconnected. Then comes the air conditioning wiring, the radiator hose clamps, the AC and power steering belts, and the radiator tank.
I'm actually going to disconnect the alternator belt, the power steering and air conditioning belt. Now disconnect the hoses to the radiator from the radiator tank. The hose that goes from the tank to the actual turbo.
Next, the wiring to the oxygen sensor and the turbo hoses to the boost solenoid have to come off, and the power steering pump have to be removed. Then the amp sensor is unplugged and the intake pipe to the turbo is loosened as it comes off with the manifold. Following this, the wiring to the coil packs and the crank sensor, water and temp are removed. The washer bottle also has to come out, and the 2 plugs of the wiring harness to the manifold and the cam sensor disconnected. Next, the brake booster hose and the 3 fuel lines are disconnected, and the variable cam plugs are disconnected and stay on the manifold when it's removed. The hoses should be checked every 1000 Ks, as they can become brittle and can snap, as was the case with ours. Finally, the 8 bolts to the manifold are removed and the manifold is put on the workbench for disassembly. First, the cover plate is removed along with the wiring clip and the fuel reg is disconnected. If it's in perfect condition, it's retained and teamed up with a new one from MRT for the dual reg setup. The 3 bolts that retain the fuel rail are then removed, along with the wiring to the injectors, before the injectors themselves are removed and cleaned up. At this point, the new fuel rails are assembled, and if aftermarket injectors are used, it's critical they're located with larger holes side by side, not up and down, which can cause lean out and subsequently a blown engine.
See how these have got 2 big holes? They actually got to sit sideways, not like long ways, because what happens, it leans the engine out. You can blow your engine if the injectors aren't put in right.
Finally, the assembled fuel rails are fitted back onto the manifold and new feed line and return lines patched in, along with the return line from the fuel reg and the vacuum hose to the fuel regs. The whole removal process is then reversed and voila! Adequate fuel is now fed into the engine. Next edition will take you through the fitment of the MRT spec fuel pump and surge tank.